Good morning to everybody who is attending this next webinar of the HealthFerm project, and a warm welcome an afternoon to Dr. Marla Cunningham. This webinar will go about novel food and health claim regulations in relation to fermented foods. Today we have 4 speakers. Professor Christophe Courtin, who is project coordinator of the HealthFerm project from the KU Leuven in Belgium. He will, of course, introduce the HealthFerm project shortly. Then he will be followed by Dr. Marla Cunningham. She is executive director of the ICEP, and she's housed in Brisbane. That's why I said a very warm afternoon for her. She will go into the key concepts in the science of fermented foods, and this will be followed by Professor Hans Verhagen. He is nowadays independent consultant, but he formerly worked amongst others for Unilever and has been a member of EFSA. Nowadays he is also a member of the Nutrition Consultants Cooperative in the Netherlands, and he will give more details about novel food regulation in the EU in relation to fermented foods. After him, Dr. Luc Peils, he is as well independent consultant, look into foods, and he worked formerly for ILS Europe amongst others, and Nestle and Coca-Cola, and is now as well a member of Nutrition Consultants Cooperative in the Netherlands, and he will go more into the details about health claim regulations in the EU as well, related to fermented foods. There are some household rules. The presentations will follow without any interruptions. You as a participant can pose questions in the question box. See questions in the webinar tool. And I would like you to address question to presenters. So indicate to which presenter you would like to address the question. And at the end of the webinar, the questions will be collected, and presenters will answer most urgent questions. And if your question is not answered right now, an answer will follow as soon as possible. So this is the way how we organize our webinars, and I wish you a lot of pleasure today with respect to the regulations that are focusing on the European conditions. Thank you very much, and looking forward to the next presentation. Marla, the floor is yours. Somehow you're muted.
Is it Christophe first, I think?
Oh, first Christophe, yes, of course, I'm sorry. First, Christophe, he will introduce the project. Apologies, Christophe. Floor is yours. Veronica, could you give the floor to Christophe?
Yes, I think now it should be fine.
Okay.
Can you see my screen now?
I see the screen of Luc somehow.
Okay. Is it now better?
No, still the screen of Luc.
For me, it's okay.
Yeah,
Oh,
for me, it's also okay, Christophe. So please go
Okay.
ahead.
Then go ahead, please.
Apologies, Jan, I will continue then if everybody can see it. And
Yep.
so a very welcome to all the participants to this webinar that is given in the framework of the HealthFerm project. So for those of you that have already participated in these webinars, you're probably aware of what HealthFerm is, but I will very shortly introduce the project to those that don't know. So bear with me for 3 slides, and then we can go to the content of today. So the HealthFerm project is a research and innovation action project from the EU, so sponsored by the EU and the Swiss government. And the aim of the HealthFerm project is to enable an evidence-based transition in society and industry from traditional to sustainable plant-based fermented foods and diets that deliver health benefits to consumers by design. I read this word for word because we have spent a lot of time defining this scope of the project, and it's always nice to be able to show it again. So what are we talking about? The transition from animal-based to plant-based diets. So we have a focus on plant materials. We have a focus on health benefits. So we want to see whether we can introduce health benefits in those plant-based fermented foods by fermentation. And we want to make sure that whatever we do is evidence-based. Yeah? You will hear later on health claims have to be evidence-based. If you go to novel foods, you have to have a lot of information, so that scientific evidence is quite important. To do what we want to do, we need to work on 4 different topics for sure. And the first topic is new microbial resources. So try to understand which microorganisms we can use for these novel fermentations or healthy fermentations. So we have to put effort in that. We have to understand fermentation technology and leverage traditional fermentation technology to do new things. And that is also part of the HealthFerm project. Again, if we want to go or if we want to talk about health benefits, we have to understand what those fermented foods are doing in our body. We can do that through in vitro measurements, but we do that also in the HealthFerm project through 5 human intervention trials that are running. We have a lot of attention for the microbiome, so the interaction of the human microbiome with the microbiome of the foods that we are consuming. And last but not least, of course, we have to understand consumer attitudes, consumer behavior towards fermented foods, and understand whether people also like the products that we are producing, yes or no, and why, and so on, so we can develop other products. So that is what the project is about. And to do this, we have gathered a consortium of 23 partners from all over Europe. We have requested the budget from the EU, which we have gotten, and we have a project of 4 years. I'm not going to single out each of the individual partners to you, but you can see the list and the logos on the lower left-hand corner of your screen. And so you can see that we have a lot of very interesting and dedicated partners there. And that makes my life as a coordinator also easy. Now, if you write a project like this, you always have to give a layout of the project in one picture. And so you see the 4 elements that I discussed before coming back. So work package 1, microbial resources, fermentation technology, human health and microbiome, and then consumer behavior. And flanking that are 2 work packages on management and on communication, dissemination, and exploitation. Now, over the last 3 years, we have talked about microbial resources. In the webinar, we have talked about fermentation technology in the webinar. We did specific webinars on work package 3, where we looked into human health and microbiome. We looked several times in consumer behavior, detailing reports that we have already written. The last webinar that we did was on omics technologies, because omics technologies, be it proteomics, transcriptomics, metabolomics, are quite important for the project. So we did a separate webinar on that. But today we will be talking a bit more about what if we want to exploit the results that we have obtained. If we have new microorganisms, how do we deal with that? What are regulations? Is it novel food or not? If we have new processing technologies that we are using, what is the status of the food products that we are going to produce? If we see health benefits in our intervention trials, which are, of course, limited in scope as always, what can we tell with regard to health benefits? So these questions have been floating around the project already for the last 3 years, because they are, of course, quite important. And so I'm very happy that today we will have answers to some of these questions, or at least insights in novel food regulation, health claim regulation, from our two experienced speakers. And it's also a pleasure to have Marla with us here from ISAP, ISAP has published several landmark papers on the concepts of food fermentation, probiotics, prebiotics, and so on. And so I'm very happy to stop now and give the floor to Marla for her introductory presentation. So I wish you all a lot of fun looking into the presentation, and a lot of interesting information coming from the speakers. And maybe also note already now that in a year's time, at the end of August 2026, we will have our final HealthFerm conference, at which all the results from HealthFerm will be divulged to the public, be it politicians, policymakers, academics, industry. So you're all welcome to attend that conference at the end of August 2026. So that's already an invitation for within 1 year. With this, Jan, I give the floor back to you and to Marla.
Thank you very much, Christoph, for the introduction. Maybe to add to your invitation of the conference, we will also organize 3 other webinars on some of the results of the work packages that will follow on as a kind of a invitation to come to Leuven. So keep an eye on the agenda of the HealthFerm project when these webinars will be organized. Thank you very much, Christoph. I understand that you will have to leave in about a quarter of an hour because of your other obligations at the KU Leuven. It's a pity, but you're able to look at the webinar afterwards, because it will be recorded, and maybe you can even present it to your students. Please, Marla, go ahead with your presentation. The floor is yours.
Thank you, Jan. Thank you, Christoph. Can you see my screen now?
Not at this moment. I still see the screen.
Yes, everything runs well. Thank you.
Okay.
Go ahead.
Okay, let me just move this out of the way. Okay. I think so. Thank you. Thank you for the opportunity to be here today to be able to talk to you about some key concepts in the science of fermented foods. There's obviously a lot of science that we could talk about on fermented foods, but what I was hoping to today is to orient us to definition some of the important some important features of what makes fermented foods and what doesn't make fermented foods, and particularly some aspects around their character which may relate to the community. So I hope to be able to set the scene in that way. I'm here today representing ISAP, and we are the International Scientific Association for Probiotics and Prebiotics. If you're not familiar with us, we're a non-profit scientific organization which was founded in 2002. And our mission is advancing the science in these fields. So one of our objectives is to identify new science in the field, identify areas where there's consensus or guidance needed in the field, and to bring together a variety of scientists, of experts from across the world to discuss these issues, debate, and reach consensus and guidance. So we've been doing that on quite a few fermented food outputs in recent years. The first one that I would share with you is probably a good place to start, is the consensus statement on the definition of fermented foods. So this was a project that we brought together 13 fermented food scientists together from international jurisdictions to discuss the scope of fermented foods, a framework for understanding fermented foods, and a definition. So you can see here on the right the definition that this group came up with. The exact wording: foods made through desired microbial growth and enzymatic conversions of food components. So this is really what makes a fermented food, what defines a fermented food from sort of some other misunderstandings in this space. So if I take you through some of the specific wording of this definition, the desired microbial growth is important because it highlights that the purpose of the food fermentation is to create some sort of desirable qualities. So we'll talk about what those could be in a moment. Obviously, there has to be microbial growth within the food for a fermentation, and there also needs to be enzymatic conversion. So it can't simply just be a food in its native form with the addition of microorganisms. There needs to be an interaction between the microorganisms and the food in order for it to meet the definition of a fermented food. I'd also point out that there's a couple of exclusions or notable omissions in this definition, which are also informative. So you'll notice that it does not say proven to have a health benefit. So a fermented food does not need to have a health benefit to meet the ISAP definition of a fermented food. And also you'll notice that there's no mention of live microorganisms here. So while the microbes must grow during the food fermentation, there's no requirement for live microbes to be there in the finished product. So fermented foods may contain live microbes or they may not. Those live microbes may be heat treated or they may even be filtered and removed, and that food can still be a fermented food. So to move on to some of the desirable characteristics of fermented foods, which I'm sure this audience is very familiar with, it may be a source of live microbes. If the microbes are retained, it may improve the taste or the digestibility of the food. So taste, lots of chemical reactions can happen, which can modify the taste during the fermentation process, as well as the digestibility. So an easy example is the removal of lactose in dairy products. The microbes may produce vitamins or other bioactive compounds. It might degrade anti-nutrient substances in the food, like phytic acid. The preserving shelf life is one of the main reasons that fermented foods evolved. Fermented foods were developed quite a long time ago. And this benefits to human health is probably something that's only more recently been explored and appreciated. Fermented foods were generally created for more practical reasons before the science on this evolved. So if we think about how fermented foods can actually have a health benefit, this next diagram from this recent paper last year is quite informative. So there's different fermented foods contain a complex mixture of components, and they can act to interact with the host and potentially improve health through a variety of mechanisms. So we've got nutritive actions, so directly providing nutrition or improving bioavailable forms of nutrition. They can contribute microorganisms, and they can also contribute metabolites or components of those microorganisms. So just to point out a few examples here, the minerals that are present in particularly plant-based foods can be made more bioavailable by the action of fermentation and release those minerals for better absorption by the host. The microorganisms which are in the fermented food can directly inhibit pathogens. They can also contribute to the beneficial microorganisms coming into the gut. They can have enzymatic activities, like the example of the lactose degradation. And the metabolites, for example, the organic acids like lactic acid or acetic acid that can be produced by fermentation, short-chain fatty acids, they can also have impacts directly on the host, so interacting with gut-brain axis or interacting with things like the gut barrier, microorganisms interacting with the immune system. So lots of different ways that the complexities of fermented foods can actually interact with the host. And this complex nature of fermented foods is quite important to consider when we're thinking about what benefits are substantiated for fermented foods, because each fermented food may produce different aspects of these metabolites or have different microorganisms, and that's going to influence the sorts of health benefits they could have. So here's a nice sample of the range of different fermented foods that can exist, and you can see they all differ from things like the format, the beverage or condiment or food. It can differ in the matrix that the food is fermented on, like grains, like plant-based materials, or animal products, or refined substances like sugars, the microorganisms that are added, the microbial metabolites that are produced, and the number of colony-forming units or live microorganisms that are present in the end. So you can expect that each fermented food is going to have different impacts on the host when it's ingested. However, I should say there are some mechanisms as well. So we'll talk about subgrouping fermented foods in a moment. So there are some fermented foods can be associated with a lot of hype in the marketplace, and there can be some overclaiming which happens with fermented foods as well. So I just wanted to address a couple of areas which can be commonly misunderstood. One of them is, the first one is that fermented foods contain probiotics. So you'll often see this on the label of a food, contains beneficial probiotic organisms, contains billions of beneficial probiotics, for example. So fermented foods can contain probiotics, but they don't necessarily and always contain probiotics. So you can see the overlap here. On the left, probiotics, you can see they're live, well-characterized microorganisms. They're defined at the strain level in an adequate dose with a researched health benefit. Whereas fermented foods often contain undefined sets of microbes. They might be they might not even contain microbes in the end product. The microbes might be dead or alive. Those undefined microbes might be at an unspecified dose in the product, and they're not necessarily researched to provide a health benefit either. So probiotics in fermented foods can actually be quite different from the sake of a scientific definition. That where they can overlap is where the microorganisms in the fermented food meet the criteria for a probiotic because of their well-defined, characterized, researched. And that might be microorganisms that are used, probiotic microorganisms that are used to ferment the food, or probiotic microorganisms that are added at the end of the food to provide a delivery source of probiotics as well. So that's whether they fit into each one of these categories is naturally going to impact the sorts of claims. Now, I'm not going to talk from a regulatory lens here. I just wanted to highlight this chart from the consensus statement because it just starts to allude to some of the issues we might talk about a little bit later in this program about, obviously the term probiotic is only going to be relevant when the organisms meet the criteria for a probiotic. If the organisms in the fermented food don't meet that criteria, here's some scientific suggestions for other phrases that might be used. Foods made by fermentation, for example, if there's no live microorganisms, or if the live microorganisms are present, containing live and active cultures rather than contains probiotics. While there's been a lot of enthusiasm about probiotics in the marketplace, there's also a lot of interest in postbiotics. So you might be familiar with the concept of postbiotics as heat-killed microorganisms or inanimate microorganisms which can confer a health benefit on the host. So these sorts of intact but non-viable microbial cells or microbial cell fragments or structures or metabolites, you can, it's definitely noted that these sorts of microorganism components can be present in fermented foods, and particularly in heat-treated fermented foods, let's say sourdough bread as an example. However, whether fermented foods actually contain beneficial postbiotics, we need to consider how well defined the microorganisms are. So just like in the case of probiotics, postbiotics need to be well defined, well characterized microorganisms in a specific preparation at a specific dose and proven to have a health benefit. So it is possible that postbiotic fermented foods can exist, but the microbes need to meet those criteria and the research needs to be there that it's shown a health benefit before the term postbiotic can be applied to that fermented food. And then the last area to talk about is, do fermented foods have health benefits? So again, there's lots of claiming about how fermented foods are good for us. And as a broad category, there is evidence mounting to show that fermented foods are good for us. But I think we need to be careful about the diversity of formats of food, the heterogeneous nature of those foods, and whether the research is actually there for those specific foods. So how do we divide up this broad category of fermented foods to actually start to study it and to start to make claims? So I pulled a couple of examples together here. These are some papers from Professor Maria Marco's lab, who's our ISAP president. Here's a review that she's put together on the impact of fermented dairy on intestinal health. They're looking at fermented dairy overall. Here's another review looking at the category of lacto-fermented fruits and vegetables. So you can anticipate, just like the difference in the matrix there, that the health benefits of these two groups could be quite different and deserve individual consideration. However, when you look at the papers, you can see that both of them are starting to show benefits for metabolic health, for digestive health, for immune health. So some of those common markers, those common metabolites and the common microorganisms that you can see across fermented foods means that the benefits can converge across groups as well. Sometimes individual fermented foods are considered too. So this was the Food and Drug Administration in the US, which approved provided a letter of enforcement discretion that it would allow a qualified health claim for yogurt and diabetes. This was based on a dossier specifically on studying the yogurt form of fermented dairy that was able to achieve this claim. And then another way of looking at how to study and potentially how to claim about fermented foods is to look at individual components of those fermented foods. So one of them is live microbes, looking at the live microbe content of fermented foods and whether that's associated with health benefits. These series of 3 papers is a project that ISAP undertook in recent years, firstly to think about would an intake of live microbes be something that could be beneficial and we could think about as a framework? Then looking at a classification system for estimating the live microbes within an individual's diet and allocating that into different tiers of microbe consumption. And then looking at epidemiological evidence to associate those live microbe intakes with different health outcomes. So I think studying the components of fermented foods is another way to look at trying to tackle the diverse nature of these foods. The last piece of research that I wanted to mention is the Pimento project from Cost Action. So this isn't an ISAP affiliated project, but we've been tracking it over the years. This is quite an ambitious project to review the evidence for fermented foods across a variety of health benefit areas and also other features like characterization and safety of fermented foods as well. So these systematic reviews are in the process of being wrapped up and synthesized into a roadmap, which should be available towards the end of this year or in the early part of next year. So I think when we're looking at the evidence for fermented foods having health benefits and potentially feeding into product claims in the European space, because these were done with this would definitely want to have been in mind to watch that space for assessments of fermented food science. Sites and a good background to some of the fermented food science, and that it's helped set the scene for some of our discussion around communication of those benefits. So thank you.
Thank you very much, Marla, for the clear introduction on the clear framework on fermented foods. I assume that a lot of people are not aware of how many fermented foods they actually consume. And that's so it makes it clear where fermentation is a good concept in the food processing. Thank you very much. That also gives a nice framework for the next presentation with respect to where can fermented foods be considered novel. Hans, the floor is yours.
Thank you, Jan. I will start sharing my screen. Just confirm that you can see my screen now.
Yes, I can see your screen.
Okay. So thanks for this invitation, and in the next 20 minutes I will present to you on the situation of novel foods in the European Union / the UK, which has the same system actually, some challenges and opportunities. It's confined to novel foods, but it is equally applicable to the subset of fermented foods and fermented products. A very short introduction to myself in 30 seconds. I did my university studies. I had a whole career of 42 years now in a variety of environments, and that you can read on your slide later on. I have formally retired, which means that I'm only working 4 days a week these days, but I have my private consultancy company and I'm a professor at 2 universities, one in Northern Ireland and one in Copenhagen. I'm a toxicologist and nutritionist. I served the EFSA and the A panel for 9 years, the maximum allowed, and I'm in the UK Advisory Committee on Novel Foods and Processes. So that's my Hall of Fame. What I shall do to you this morning, I'll give you an introduction into the area of novel foods. Then I will identify applicable regulation, the role of EFSA in the scientific evaluation, and I will identify some issues and challenges later on. First, we're talking about novel foods. There is frequent confusion about functional foods and novel foods, and you can see them here in my scheme. The entire food realm is very wide. A subset of it is functional foods, and these are associated with claims, and that will be the subject of the next lecture to come by Luc Pels. Novel foods are evaluated for one purpose only, and that is safety. That's just what I sorry, and that's what I will talk on about this morning. There's a definition of novel foods. Novel foods are foods and food ingredients that are not used for human consumption to a significant degree in the European Union before the 15th of May 1997. Let's go into some history of foods and novel foods. First, look at what have we been eating over the centuries. In the early days of mankind, when we were hungry, we were going into the woods and we were collecting berries and roots, and we were hunting a deer or a mammoth, and we had sufficient food for a long time. Over the years, as you can see, for the Greeks and Romans, we have been preserving foods, keeping foods for longer, as you can see, across the lines of history. And nowadays, when you want food, you go to the shop, you go to the supermarket, and you buy the foods that you like. All these foods are clearly not novel. Recent centuries, we have sailed the oceans and we found new foods that were not originally in the European Union, but they are now part of our diet, like tomatoes, maize, potatoes, bananas, herbs and spices. They have been a part of our diet for hundreds of years. These are also not novel. The cutoff date for the regulation is the 15th of May 1997, and anything that enters in the market is potentially a novel food. Some examples of novel foods, and these are slides from EFSA. It could be nearly synthesized or isolated compounds like lycopene in a synthetic way, or non-sticky chewing gum bases, eye-structuring protein developed by Unilever 20 years ago. Novel foods can also arise from new sources, krill oil, omega-3 long-chain fatty acids, or lycopene, but this time from bee spora, unlike a synthetic lycopene, or astaxanthin from another microorganism. Novel foods can also reflect to novel processes, like UV-treated milk or UV-treated yeast in order to increase the vitamin D level, or milk products fermented with Bacteroides, Xylella solvens. This has not been a food in earlier days, so it is novel. And novel foods can also be traditional food from non-EU countries, like chia seeds or baobab fruits or noni juice. And there's more and more, there's dozens of examples there. But let's look at applicable regulation. The applicable regulation in the European Union is the 2015 regulation number 2283 on novel foods. As you can see here in my slide, this regulation is in place from the 1st of January 2018, and it follows on an earlier regulation. It makes a distinction between full novel food applications and notifications which apply to traditional foods from third countries. Alongside the regulation, EFSA was asked to issue 2 technical guidance documents describing how a dossier should look like. And there's a series of auxiliary regulations in order to make the overall regulation work. What happens when you make a dossier? For a novel food regulation or notification, all dossiers go to the European Commission. For applications, you are responsible as the applicant. You make a dossier, send it to the Commission. The Commission does 30 working days for validation, and once the dossier is considered valid, it is handed over to EFSA to do the scientific risk assessment, for which they have 9 months available, which can be extended if there are any requests for additional information. At the end of the day, the EFSA and the A panel will adopt the scientific opinion, which is then published, and that is then the onset towards authorization or not, depending on the outcome. That's a role for novel food applications. For novel food notification, this applies as a more simplified route for traditional food from third countries. Again, it starts with the applicant. The applicant makes a dossier, sends it to the European Commission. The Commission has a month to validate the dossier and then sends it on to both EFSA as well as the individual EU member states. EFSA and the member states then have 4 months to issue any what is called duly reasoned safety objections. If there are no objections, then authorization can follow quite readily. If there are duly reasoned safety objections, the dossier is handed over to EFSA to issue a scientific opinion and do the risk assessment evaluation. The goal of a novel food application and notification is actually very simple. You must establish that the novel food is safe under the proposed conditions of use and that the novel food is not nutritionally disadvantageous. In fact, you need to convince with your dossier the body that evaluates the dossier, which is typically EFSA, and for traditional food from third countries, also the member states. In my practice as a consultant, I see one question arising many times. Is my food or food ingredient novel, yes or no? To this end, there is an auxiliary regulation, that is the regulation 456, it refers to Article 4 of the original novel food regulation, whatever number you prefer. Here, the route is as follows. If you have doubts or you want to confirm that it's not novel or novel, the onus is again on the applicant. You make a dedicated dossier. That dossier is sent to one of the EU member states who has 4 months to come with a verdict. And the outcome of this evaluation is entered in what is called the Novel Food Catalogue. The Novel Food Catalogue can have different options. It can conclude that your ingredient or your food is not novel. Okay, then I would say congratulations, you can proceed. Or it can conclude that it's not novel in food supplements, but it's novel in foods. It can also conclude that it's fully novel, both in foods and in food supplements. Or there can still be question marks. Alongside, you must consider that if it's considered novel in foods or fully novel, it needs to be followed up by a full-up application. It can also conclude that it's already an authorized novel food or that it's not listed and there's a very special occasion. So use this regulation if you think that may help you. The Novel Food Catalogue contains hundreds of entries. And here you can see an example, but please realize that it's an informal record of discussions at the EU level about the novel food status of numerous foods and food ingredients. But if you have a food ingredient or a food that you would like to consider, the first thing you shall do is look at the Novel Food Catalogue, see if it has been considered already before. Okay. Suppose the novel food dossier goes to EFSA for issue its scientific evaluation. To that end, EFSA has written and published a couple of guidance documents. The first guidance document was published in 2016, revisited in 2021, and has recently been significantly updated in 2024 with much more specifics, more details, and more examples in order to help you to make and prepare a good dossier as swiftly as possible. The guidance by EFSA is divided into 10 different chapters. It starts with the identity of the novel food, its production process, its compositional data, and these three chapters leading into the specifications for a few novel food or novel food ingredients. Alongside, you need to present data, if available, on history of use. You need to determine its anticipated uses and calculate the intake across age and gender and population groups. In addition to that, you need to provide data on ADME, absorption, distribution, metabolism, and excretion, toxicological information, nutritional information, and information on potential allergy. These are the chapters of a dossier. What I experience in my practice as a consultant, it can be complicated, but you should follow it as meticulously as possible, and in order to make it a clever dossier. Do whatever you need to do, but don't overdo it. Convince EFSA. Likewise, EFSA issued a guidance on the notifications for traditional foods from third countries. Again, the original guidance was published in 2016, updated in 21, and the real update followed also last year in 2024 with much more details, more specifics, and more examples. The chapter for a notification dossier is similar, albeit not the same as for a full application. It starts with the description of the traditional food, its production process, compositional data, leading into specifications. In addition to that, you need to provide data of continued use for at least 25 years in the third country outside of the European Union. In addition to that, you need to identify the intended target population, the proposed uses and use levels, the intended role of the novel traditional food in the diet, and if you know any precautions or restrictions of use. The chapters in green, description, production process, compositional data, specifications, and continuous use for at least 25 years, these cover what is called a history of safe food use. You can imagine if it has been in safe use already for at least 25 years in a third country, that is some affirmation of the safety of the novel food. And the chapters in blue, they are the proposed conditions of use for the EU market. The outcome of a dossier evaluation, either an application or a notification, is binary. The conclusion can be that the novel food is safe or not safe under the proposed conditions of use. And here we identify who does what. It's up to the European Food Safety Authority and somewhat to the EU member states to do the scientific evaluation, the risk assessment. It's up to the Commission and the member states to make a decision on authorization. That's the risk management part. In Europe, as well as in nearly all the places in the world, we have a clear separation between risk assessment and risk management. The Commission and the member states decide on authorization if they have a positive information and conclusion from EFSA and the member states, and a positive authorization decision follows. The decision is laid down into what is called the Union List of Novel Foods. And here we make a distinction between the former Novel Food Catalogue, which is an informal record of discussions at EU level about the status of a novel food, yes or no novel, and the Union List, which is a formal authorization list of novel foods that have gone through the process and made it until authorization. Let's go for some issues and challenges in the procedure, because it's never simple, of course. The first thing I would like to notify here is the transparency regulation, which was published in 2019 and came into force in early 2021. In a nutshell, the transparency regulation implies that your dossier will be in the public domain. With some asterisk there, those parts that you consider confidential and where EFSA agrees to the confidential status of that part of the dossier is not in the public domain. What is in the public domain is there for public consultation before the EFSA evaluation starts. It's also relevant to note that the studies that will inform your dossier need to be notified to EFSA before they start. If you forget about it, you will get an automatic penalty of half a year. So don't forget to notify all the studies. Alongside, it's also possible these days to have pre-submission meetings, and I experience that this is highly appreciated by the applicant, to discuss with EFSA staff, not with the panel, before you submit a dossier. It's not compulsory, but it's a possibility. So make use of it if you think it can help you. Another issue these days is the avalanche of novel food applications. When I started working on novel foods in EFSA in 2006, we had around a handful of dossiers each year, which was a lot of work. But these days, since the update of the regulation in 2018, you can see there is a real avalanche of novel food dossiers. Around a tenfold increase in the number of applications. And I realized that the people in EFSA must be working their socks off in order to get this done. But that's their concern, not mine. Another issue with respect to novel food regulation is the long time for the risk assessment. You realize that the update of the regulation was there and the guidance of the EFSA was there to make life easier and faster and more clear. The formal regulation says that there is 30 working days for the suitability check and 9 months for doing the scientific risk assessment. In practice, that does not work like that. So a very gross estimate of the overall turnover time is in the area of around 3 years still, because of request for further information and clarity into the requirements, etc. So I cannot do anything about it, but something to realize. There's also a recent paper that was published. It was evaluated how long it takes for a dossier to go through the system, and it is indeed in the area of around 3 times, which has led to comments in the press, in the scientific press. Long delays in novel food approvals put Europe at risk of falling behind, and there's more and more of this. It's something to realize. Anyway, the take-out message for me would be do a good job and as good as possible. Another issue is the maze of EFSA guidance document. It's not only the novel food guidance that you need to follow. There's also a series of administrative guidances. There's a series of scientific guidances. I will not read them out to you, but life can be more complicated than anticipated. Alongside, what I think personally, there is also a gray area of novel foods. Here I drafted a paper about 1.5 decades ago about an explorative study into the gray area, because I have the intention that there's many foods and foods ingredients on the market that could or should potentially be considered novel, but never go this route because it is not entered. It's the food business operator who is responsible to trigger applicable regulation, and if he or she doesn't do it, it may go unnoticed until enforcement. So I think there's many great novel foods on the market, and this is an issue of enforcement versus marketing versus food safety and public health. Some examples that we identified 15 years ago are also in the area of pro and prebiotics. There's some examples here in this slide. It's a bit tailored towards the Netherlands, but I can invite you go to the original publication, which was also authored by the former chair of the ISAP, Seppa Salminen. Another issue to take care of, this is complexity of an application dossier. This is a mapping of requests for further information by EFSA over series of novel food applications. And you can see that there's in many areas that EFSA may ask questions if there are unclarities. I would also invite you to read this publication from 2020 by the EFSA staff, mapping all the requests for further information topics. In this update of the novel food guidance, EFSA has done something that I really appreciated. In 3 areas, in the ADME area, absorption, distribution, metabolism, and excretion, in the genotoxicity area and the repeated dose toxicity area, EFSA says start with literature data. If you can come with convincing data that inform the safety, it may not be necessary to do subsequent tiers. So I think this is a new stance, an updated stance of EFSA, and I highly appreciate that. And the final issue that I would like to identify is in the area of cultivated meat. I realize this is not exactly the same as fermentation, but it's close. And the aspects in cultivated meat also inform fermented foods, I would say. Cultivated meat was first introduced in the world in Singapore. Singapore novel food regulation works more or less the same as in Europe, like in all places. They evaluated a couple of dossiers, concluded positively, and in Singapore it's now on the market. Likewise, in the US, similar dossiers also made it into market introduction. In the EU, it's a void still. A few dossiers have been submitted in the meantime to the Commission and is under evaluation by EFSA, and we will eagerly wait the outcome. Hopefully not 3 years, but that is to say I'm not involved in there. We also had cultivated meat in the Netherlands. It started in 2013, and in 2022, it was followed up by a stimulus of the Council of Ministers in the Netherlands to stimulate cellular agriculture. 60 billion euros invested, leading to the development of cellular agriculture Netherlands, which identified that tastings are an important enabling factor. But that results in a catch-22 situation for tastings, because cultivated meat is a novel food. So tasting would not be allowed because safety has not been established. But investors are not inclined to invest if tastings are not possible, and that's the catch-22 situation, which was brought into the Dutch Parliament via a motion, and a motion that was adopted said that tasting should be possible under certain conditions. This has led to the development of what is called a code of practice for tastings of cultivated meat prior to the EU approval. I will not go into details, but it heavily focuses on the individual constituents that are in the cultivated meat. What you need to identify, an applicant needs to identify the individual constituents, the total intake calculated per person in kilograms per body weight, identify whether these values are calculated or actually measured, comparison with health-based guidance values, and then conclude whether they're in the green area when they're below health-based guidance values, or in the orange area when they're above, and then they need special consideration. Such simplified dossier is evaluated by a committee of experts comprising of a toxicologist, who is the chair, an expert in microbiology, a physician, and an ethical expert. To date, 3 tastings have been taken place in the Netherlands, and we are the first in the EU. The first one was in April 24, and that was quite successful, as you can see here in this slide, and the resulting outcome was that it has a very artisanal taste, as you can see here. Anyway, that was what I was going to tell you. I thank you with the last presentation of my slide, looking at agriculture over the ages from minus 5,000 years ago, 500 years ago, 50 years ago, and in the nearby future. That's a personal view. Okay, I thank you for your attention, and I hand back to Jan.
Thank you very much, Hans, for the clear overview of the complexity of the novel food regulation and adherent regulations, and the pitfalls that companies may encounter. I now hand over to Luc Pijls, and he will go a little bit more into detail on the health claim regulation. Luc, the floor is yours. You're muted.
Ah, yes. Okay.
Yeah.
Thank you. Let me put my keynote screen. Good morning, everyone. Oops, let me put this away. Just a second. Yes. Is this okay? You see my screen? Can anyone? It's okay.
I see the other part. I don't know what Veronica is seeing.
Ah, Veronica,
Yes,
can you confirm?
Yes, you're
It's
still
not in
in
presentation
mode.
mode.
Okay.
Is it in presentation mode? Can you confirm? You see it?
No.
Again, I go again. Now?
No.
Is it? Oh, my screen is in presentation mode. Okay, then let me see. Maybe I have to do it differently. I choose another option here. I choose the whole screen. I choose whole main screen. I go back to my screen. And now is it?
Yeah, now it is perfect. Thank you. Oh, now back.
No,
No. Yes.
Okay.
Now it is.
Okay. Yes. Good morning, everyone. Thank you for having me here. The message that I have for you is that one shall claim only what has been substantiated. That's the key principle, the key rule in the EU and also in the UK. And so this is the message, but I will elaborate a bit on this message. In substantiating what one wants to claim, there's a guiding principle. It can be said like this: in God we trust, or may trust. All others must bring data. I was told that this is written above the gates of the American Statistical Association some time ago. I'm afraid by now it will have been removed. But in substantiating what one claims, this is the guiding principle. One must bring data, and one must bring data that show what one wants to claim, state is actually true. That's what substantiation means. So where are my manners? Let me introduce myself now. My name is Luc Peijls. Since 10 years ago, starting in Brussels, I have run a company called Look Into Food, which have moved to Utrecht some years ago in the Netherlands, and it seeks to advance and apply nutrition science through regulatory affairs, communication, and research. I am one of the members of one of the consultants in the Nutrition Consultants Cooperative, as is our previous speaker Hans Verhagen and our moderator Jan de Vries. And this is where I come from. These are the hands of my father. I'm a farmer's son, and I started in the area of nutrition after being at the farm, being surrounded in food production. I studied nutrition and epidemiology in Wageningen, during which I worked actually in Ethiopia. And let's make a side step here. We worked on a very interesting fermented food. It's fermented encephalitis ventricosum, also known as false banana. I'll show a picture in a moment. It's a big banana-like plant, which has a big tube also, and the pseudostem and the root is chopped up, put in the ground, left for years sometimes, ferments, and is used for staple food for tens of millions of Ethiopians. I worked at National Institute of Public Health, worked in medical nutrition in Amsterdam, worked for the Health Council of the Netherlands, worked in ILSI Europe. Interestingly, by the way, in the Health Council, I could write an advice for the minister at the time on health claims and substantiation of health claims. In ILSI, I had the pleasure of being involved and also co-writing PASS claim, which is on the substantiation of health claims, which became EFSA's first reference in their guidance on how they were going to look at the substantiation of health claims. And after that, I worked more on European projects, then moved to Switzerland, worked with the largest food company in the world in their research, aimed to guide the researchers in the different areas to ensure that their research was fit to answer questions that need to be answered if you want to substantiate health claims on, for example, probiotics. Works also in the medical nutrition field, to then go to the Happiness Factory as the global director for nutrition innovation, and then arriving at Look Into Food, where I've arrived 10 years ago. And I'll continue from there. This is just to show you, and maybe it's of interest, we worked on this 35 years ago, we published on it, This is the plant that is chopped down from top to bottom, put in the ground, fermented, and we did studies on the agricultural aspects, but also nutritional aspects of it. It's published if you're interested also for this HealthFerm forum. Maybe it's of interest to you. That was a side pass. So now, to be fully transparent, I have some interest for you to decide if you think it will conflict with me giving you an unbiased perspective on what on the ins and outs of substantiating a health claim in Europe. What I do basically, one of the things is work for companies who want to understand what they are allowed to say about their foods, but I'll also work for non-profit like this Health Council in the Netherlands still later on, or EC projects, etc. We are talking basically about in this session by Hans and by me. We're talking about the law basically. If we take one step back, maybe good to put in our minds what does the law demand for food? Basically, well, it prohibits two key things. It prohibits harming and it prohibits misleading of consumers. And Hans talked about novel foods. A novel food regulation exists so that new foods to be introduced that we do not know the safety of cannot just like that enter the market. So it's about avoiding harming. And health regulation, as you can understand, seeks to avoid the misleading of consumers by thinking into the to avoid misleading that in the idea that foods have certain properties or benefits that in reality they do not have, or we do not know if they have them. That's what I'll focus on now. So apart from the novel food regulation Hans shown, there's another regulation here, 1924-2006. It's not from the year 1924, but it's from the year 2006. So this was all prepared in the time that I myself was working in the health claims and health council in the Netherlands on claims. So it was a nice interaction at the time. And then it came out 2006, entered into force in 2006. One of the preambles, 23, says that the claim should be authorized, meaning the substantiation should be, the claim should be authorized only after assessing, after the scientific assessment of the highest possible standard of the substantiation of the claim. Well, Look into Food didn't exist yet, so that's why they found another organization. Silly joke, sorry. The European Food Safety Authority was mandated to provide this scientific assessment of the highest possible standard. This means, has been interpreted by most people, rightfully so, I think, meaning that the scientific bar is put really high. Other people I remember at the time, they argued, no, it doesn't necessarily mean that the bar must be put very high for the scientific convincing level of the substantiation. It just means that the way it is assessed must be scientifically of the very highest possible standard, must be done the best possible scientific way. But I think what we see, what happened, and I mean, I think it's good that in Europe we have now more or less the strictest evaluation and authorization procedure. The bar is the highest of all the world. I think before you are allowed to say that food X gives you health benefit Y, and that we talk about today. Another side comment, maybe good to know that also already before Europe adopted all this, Codex Alimentarius had their own guidelines for the scientific substantiation of health claims. And this is basically, has been like a blueprint for what we are doing in Europe. But it's basically, it's not even so special in the sense that it's most of it is scientific common sense. And I cannot tell you how often I have had to explain to people when they say after this, after that, and they said, well, they're applying scientific common sense, and they apply to the fields of evaluating the basis scientific substantiation of you saying that this is good for that. So EFSA hasn't invented the idea that if you wanted that you do a controlled study with a placebo group next to an intervention, etc. So I had to explain that many times. So these claims, what is a claim? Basically, it's a statement about something. And when we talk about health claims, basically in the terms of the EU regulation and what the UK is also decided to keep doing, there's two types. There's a nutrient content or nutrition claims. They talk about what is in the food, and it stops there. For example, high in calcium. Or you have the other claims, which go one step further, health or functional claims. They do not only say what is in there, but also they say what does the food do. Let me see. So for example, calcium playing a role in bone health. If we look a bit more closer in this first left box, the content claims, you have an annex to that regulation I just mentioned, 2006, which gives you all the options for nutrient content claims, and they mostly are formed in this is a source of, this is high in, this contains, it's increased, it's light, it's low, and you have all values and numbers, minimum and maximum amounts of nutrients and energy and etc. you need to have to make these claims. Quite straightforward, even though even this can be tricky at times. If we go back to have the overview again, we see the nutrient claims here on the left. We have health claims in the middle. They are the functional ones. For example, a tomato extract will improve your flow mediated dilatation in your blood vessels. You have, that's what we called Article 13.5. There has been, by the way, a big bucket of claims that has been evaluated in the beginning when this was introduced. I'll come back to that later. But apart from the functional ones, there's the Article 14 ones, which combine disease risk reduction claims and claims on children's health and well-being. Disease risk reduction claims is a classical example is the one of plant sterols, reduces cholesterol, full stop. Cholesterol is a risk factor for cardiovascular disease. You have also claims that chewing gum decreases the amount of plaque on your teeth, full stop. Plaque is a risk factor for caries. There's another type of claim on the right, medicinal claims, which are defined by law as any claim saying that something can help prevent, treat, or cure a disease, like calcium intake can treat or cure osteoporosis. They're not allowed by law. They're only allowed for medicines. And if you make such claim on any product, you make your product into an illegal medicine. Of course, foods can prevent, treat, or cure diseases. Like when you have scurvy, you can treat it, cure it with oranges, and surely calcium-rich foods can help with the prevention of bone fractures, but you're not allowed to call it like that, because let's face it, prevention, when you take a flu shot, you reduce the risk, not to zero, but you just reduce the risk of getting a flu. So technically, scientifically, prevention and disease risk reduction are very much similar. So we put a red cross to those ones on food. Zooming in on the health claim, it's basically any text, but also graph or picture, so not just explicit text, but also graph or picture, that states, but also implies or suggests that a food has a certain effect beneficial for your health or your function. So this is important. It's not just what you explicitly say, but if you put a shield on a product for babies or small children, you're implying some kind of protection. It's not without consequence. If you put such a shield, for example, if you put a heart, it's considered very strictly, if you like. So it's important to bear that in mind. So then we zoom in on this substantiation, which is the crux of the matter. A substantiation means scientific substantiation, meaning that what I started with, you have to substantiate what you claim. If you claim that this is good for that, you have to able to show the data that this is actually good for that. It's like a bridge with two pillars, with on the one hand, you need to have something, a food or constituent thereof, that is sufficiently characterized. On the other hand, you need to have be looking at an effect that is actually relevant for your health. And these two have to be connected by substantiation, meaning by scientific data, a totality of pertinent evidence that shows that eating this well-characterized food actually causes this effect that can be considered relevant for your health. And if we zoom in on these 1, 2, 3 parts, you can look at the food characterization. Why is it so important? The crux of the matter is that anyone should be able to verify that if a company later on sells a certain food or constituent with a certain claim, to see that what is being sold is actually the same thing, because it can be checked because of the proper characterization, is the same thing as the stuff that was tested and the data of which are shown in the application upon which the claim was authorized. Also for fermented foods and constituents, for example, bacteria or their metabolites, all this applies. So let me stress this, everything that we're talking about today for novel foods and for health claims, there are no specific rules for fermented foods or their constituents. the same principles applies. If someone thinks that they have a fermented food in their hands or constituents thereof, like the bacteria or the metabolites or combination of that, and they have a health benefit, great. You have to show the onus on the applicant. You have to do the proper studies, and if they show that what you are saying is true, then you can get your health claim authorized. So the same scientific common sense must be applied to also this category of foods and their constituents. There's all kind of details that can be involved in this proper sufficient characterization. I'll not go through them, but there are some of them. Then we go to the other side of the bridge, the other pillar. Of course, what you measure, the effect that you want to claim, should be relevant for health or your bodily function. Why is that so important? Because, well, when I drink a glass of water, already thousands of things happen in my body. Doesn't mean that all the things that happen that I can measure are relevant for our health. So we need to show the relevance for health or functioning of the effect that we want to talk about. Why? Because if not, then the claim is pointless and misleading. So we have looked at the two pillars. Now we go to the, maybe it's this one. Let me show you this one. When we talk about measuring things, it's interesting. Over times, I've come across so many terms that one can use for parameters that one measures. And here's a snapshot of them. Not going to go through them. But my message here, it doesn't matter what you call the thing that you're measuring, as long as the thing that you're measuring reflects something that is relevant for the health or functioning of the consumer who is going to eat the product. And then we come to the connecting of the two pillars. You need to have the sufficient data. The totality of relevant pertinent evidence must show that the intake, consuming the food constituent actually causes the claimed effect. And for that, we have, let me say a few things about it. The core in this is studies in humans, preferably intervention studies, where you have subjects that are representative of the people to whom you want to sell the product later on. There should be a proper control group. The study should be long enough to have a meaningful period, to have an effect during a meaningful period. There should be an intake that can be realized in practice. The outcomes, as we just said, should reflect something meaningful. They should reflect the effect they're going to claim. So if you want to talk about bowel well-being, you can look, for example, at the frequency with which you go to the toilet. There should be, well, this is, again, it's also scientific common sense. The effect must be, not apart from statistically meaningful, the size, of course, must also be meaningful. Losing 50 grams of body weight in 3 months with a certain product, even if it's statistically significant, it's not meaningful. Probably you want to see more than one study, because we know, unfortunately, in reality, many studies that have been once, that have been repeated, do not reproduce the effect. So we like to see the effect replicated at least once after the initial showing of the result, and the totality of the evidence must be considered. No cherry picking. Hans mentioned already the transparency regulation, which even if you would want to cherry pick, it's over. You cannot do it. If you do not announce a study before you're going to do it, you cannot use it in your application, or you can, but you'll get some penalties in a variety of ways. So no cherry picking. Here, with courtesy to Hans Verhagen, I lent a few of his slides. He's a professor. He's teaching much more often about this than I do. I know a lot about it, but not so often teaching about it. If you look at some examples, here you see some examples of the topics that health claims have been asked, that have been applied for, and sometimes granted. I'll come back to that. Interestingly, I think for the topic of today, fermented food, is what happened with microorganisms. At the time, in the beginning, more than 100 probiotic microorganisms claimed to be probiotic were submitted for their health benefits, and more than 100 already were pushed back in the first step, meaning they were not sufficiently characterized. So there are no approved health claims for products at all, except for one. We come on that, but nothing on immunity. Only one claim on some yogurts bacteria in yogurts that can help if you have a problem with digesting lactose. Why did so many companies at the time jump on the probiotics? I've been explained that probably it was because basically, even though it went completely wrong, one bacteria, if you characterize it properly, you can kind of own it in a certain way. So it makes it's something that you can own as a company. It's easier to own that than, for example, an antioxidant. But it didn't work out as they wanted to work it out. There was an essay at the time. People had been quite optimistic and maybe even overestimating themselves a little bit when they demanded a strong healthcare regulation, especially the big companies wanted it. And then it turned out slightly different than they had hoped for. Botanicals, to mention, I come back to that also. Apart from that, the characterization often not good. For in most cases, the data do not show properly, convincingly that they have a beneficial effect. I come back to that in a moment. And here, this one, you see, this is also for courtesy to Hans Verhagen. Thank you, Hans. An overview of the different types of claims in different articles. And bottom line is, basically, if you go to the right, you see that for most types of claims, except for the disease risk reduction, only 1 in 20 kind of made it. The 1548 in the middle, those are basically most of them are the claims on botanical products. And the situation there, how do I summarize it? Most of them have not been properly evaluated by EFSA, because there was it has been suspended because basically there was a big fight in Europe. There is the camp saying, well, if you want to claim botanical is good for you, fine. You have to follow the same rules, same as everyone else, show your substantiation. And that means that the consequence will be that many will not make it. And there's another camp saying, oh, no, but they're special and need special treatment, they deserve the special treatment. So it's still pending. Under certain circumstances, you can still talk about their effects until further notice. It's all registered. There's a register online available. I show a screenshot here. You can select authorized, non-authorized claims. You can find all the opinions for all the thousands of claims. It's a very good repository. Interestingly, so that you can, and then to almost conclude, for every claim, you have the scientific evaluation by EFSA, and in the risk, what's it called, risk analysis, tripartite situation, EFSA is the risk assessor. Then you have the European Commission with the member state, the other risk managers. So they will talk about how can we word this claim. They do not necessarily authorize a claim with a positive opinion. Look at caffeine, for example, has all kinds of effect in the body, but we have no authorized health claims, if I say it correctly, because it was, from the risk manager point of view, it was considered not a good idea to have too many claims on, for example, energy drinks and all that. So the risk management is in the hand of the European Commission and the member states. The final wording also is agreed on that level. EFSA provides a scientific wording that they say, okay, this can be substantiated, and then the member states and the European Commission decide on the final wording and potentially probably also condition of use. How much of this should one eat and who maybe, or what restriction might apply? In some cases, I will not elaborate, but there's exclusivity for 5 years to make that claim, like for novel foods. By the way, most of the stuff that Hans explained about the process is exactly the same for claims, so I do not need to repeat all that. And know that then the European Commission, eventually mandated to do so by the European Parliament, is the one who authorizes formally the claim, and then it's added to the official list of authorized claims. And then it's on the national level, nothing to do with EU, to control as little as they want, to do controls and checks on whether companies stick to using only authorized claims and in the right way, with the right wording and the right conditions. Having said all that, if you want to learn more, Hans also mentioned there's EFSA guidances, general ones and specific ones for claims. There's guidance from the EC. The EFSA opinions themselves are very educational. If you want to see how they look at these matters, and I repeat, it's scientific common sense at large. EFSA hasn't invented anything outrageous or special, very different. No, it's scientific reasoning, and the onus is on the applicant to come with a proper story and data, and EFSA will evaluate the convincingness of that. If you need more help, there's Look into Food, there's Nutrition Results Cooperative, and with that, I give the floor to everyone else, as the art of asking questions is the source of every progress I learned in Brussels sometime. And with that, I give the floor back to our moderator, or maybe to other people in our
Thank you very much.
Thank you.
Yeah, thank you very much, Luc, for the clear presentation on the health claim regulation. Can I ask the other presenters also to open up their cameras? Yes, thank you very much. Yeah, there's Marla as well. Actually, I do have one key question. If you look at and that links definitely to both the novel food regulation and the health claim regulation. If you look at safety, novelty, or functionality of a fermented food, then what I can recall is that there is a huge bunch of fermented foods that may have a history of use, safety of use from different continents. However, how can you guarantee the safety and history of use and functionality of these fermented foods? Because how can you demonstrate that the microorganism that you measure now, that you can identify now, is the same as 25 years ago, 50 years ago, 75 years ago, or whatever? And I think that's the main question that we have to address when looking at novelty, safety, functionality, etc. Who can I give the floor?
I would say, Jan, this is a rhetoric question. Yeah, you can hear me, yeah? Yeah. I would say this is a rhetoric question. You need to use a starting point that what you are bringing to the market is, what you are evaluating is representative of the material that you are marketing. So if you, as a food business operator, consider that what was on the market or in use 20 years ago, 50 years ago, 200 years ago is the same as what you are not having now, then you're good to go. Then you're probably not novel. Then apart from the health claim, let's say what does not work these days did not work either 200 years ago. So you need to come up with the evidence.
But we know that mutations are very common, and that's
and it could qualify for a new novel food, and that's a gray scale.
Yeah, but
maybe if we can turn it around, the onus, basically the responsibility is always the food business operator. So if you have something like a food that is made produced with bacteria, based on something that bacteria do, and you have at some point in time shown that the bacteria at that time were are safe and producing stuff that was safe, and you have maybe shown at the time that the bacteria as they were at that time, or the metabolites, had a beneficial effect, great. But if you know yourself that this changes, basically the onus would be on you as the food business operator to show. If you want to keep selling it, you might want to be ready for the question by an authority asking you, it might have changed. Can you still show us that it's still safe? Or same for the benefit, you say it's good for that, but we know it might have changed. So the onus is always on the food business operator to ensure that it's still safe and that it still has this beneficial effect that you're claiming it has. It's not for authorities. You see, authorities can ask you, can challenge you. The onus is on the food business operator, responsibility.
And how do the regulators look at the continuously improving way of improving methodologies to demonstrate what type of bacteria you have? To what level do you need to go if it's about demonstrating that this bacteria X is the functional bacteria if it's coming to fermented foods. Do you go to have the species level, subspecies level, subspecies level, or even further? Because there is quite a grade of microbiological approach in that sense. Maybe Marla can elaborate a little bit on that.
Yeah, so I think it's for a probiotic, genome sequences are done frequently throughout manufacturing to identify any genetic drift that's happening. So performing regular genome sequences is an important part of probiotic manufacturing. But for fermented foods, there's not necessarily characterization even of the microorganisms that are going into that food. So for me, that's a bit of a grey area as to how that's regulated, and I'm not familiar with how it's done in Europe. How those microorganisms are actually even, identified and tracked throughout fermentation processes and batches.
It is a key question that pops up in the HealthFerm project regularly if we are discussing about beneficial effects of fermented foods that we at this moment are producing on the basis of the results of the project. So that's why I posed this specific question: to what level do you have to demonstrate what bacteria? Because I know for probiotics you have to demonstrate characterize your strain to a certain level. Do you need to do that with fermented foods as well? Maybe Hans, Luc can provide an answer on that.
Well, shall I give another go, if you allow me, Hans? Yeah. So, well, I think I kind of repeat myself. It's the onus is basically again here. So I was explained at some point that like for bacteria, one subspecies of the other might be as different as us from a goldfish. I don't know what. So if I have a product with bacteria in there that do something, that ferment, that make metabolites, it's for me to show. If I can show that a certain that I do not that for a certain species of bacteria, including all their subspecies, if I can show, if I data that make it reasonable to assume that all the subspecies belonging to this species do the same thing, then I show these data, and if it's convincing scientifically and technically, it's fine. So I don't think you will never find a regulator who tells you generically across the board you need to have this level of detail. It's always the other way around. You have to show that if you the more broad you go, that in that broadness you have reason to assume that the same safety still stands, and that the same health benefit is probably going to happen. You see, that's how it works. That's the direction I think we have to look at. I don't know, Hans, you agree or?
Yeah, I agree with what you say, Luc, and I also agree with Jan, except for one word. The question was very good, but one word too long. You asked how do authorities, etc., and I would say not how, but do authorities enforce. And let's say the enforcement, because that's the magic word there in the health claim area, is, I think, meager. Last year I published a paper on the let's say conformity of health claims practiced in those days in the UK, but they have the same regulation. Conformity was 90%, which means that 10% was not in conformity with the regulation. With respect to novel foods, I already alluded to the concept of what I call gray area novel foods, and again, that's an issue of enforcement, and quite regularly I touch upon issues with authorities that are think that some product may jeopardize public health, or they think something may be a novel food, and it's not fully black and white. It's a matter of taste, and I had examples where, let's say, a clear-cut probably novel food was not considered novel, and the other way around, where something that was, let's say, in my respect, 100% similar to something that was already on the market or in your body was considered novel. So it's not 100% clear. and that could call for an endeavor to bring more clarity, but even then the gray areas will remain, probably less.
Yeah. In that perspective, someone asked as well that, or states as well that it will become increasingly difficult to demonstrate a history of use, because there is a fixed date, 15th of May 1997, and we just proceed in our life and the time flows. So in about 50 years, history of use will become more difficult to demonstrate. So how can you elaborate on that?
Yes, the magic date of May 1997, that will remain. It's just an arbitrary date. The entry date of the novel food regulation, the formal version of it, and indeed it could be become more complicated than when we were 2 centuries ahead. Yeah, but that will not be our concern of me or anyone in the audience, I think, but it may be true. Maybe there will be an update at some point in time that the cutoff date may change. I don't know.
I can add to this if I may, because as member Hans, I know you may have been involved in the discussion as well, because I know at regular occasions the discussion comes back to the Commission to let go of the fixed date and have a rolling date, to have, like we already have these 25-year history of safe use option, which is kind of similar to the idea of the 1997 date. The idea is in novel foods. I mean, if you step back, the concept, the idea is that if something is new, we're not sure if it's safe. So we look back and then we say either it was already used before 1997 and we don't know of any problems. You have to always say that in between the lines, you don't have problems, so it's probably safe. Or we say, well, it has somewhere in the world been used for 25 years consecutively, and again, we don't know of any problems, so it's probably safe. So it's not unthinkable and unreasonable to apply this 25-year consecutive use to Europe also. And I know discussions, I've seen them through the years coming back to the table and then pushed away again, coming back because it's fair and reasonable to do, but pushed from the table again because it's just complicated to change it. I think that seems to be the game that is being played out regularly. For now, it's how it is. Yeah.
Yeah. Okay. Just one last question. I see that we are slightly over time. To Marla, does the efficacy, the dosage for the effectiveness of probiotics or fermented foods vary based on the regions due to the difference in the gut microbiota and variations of the diets? So some already eat a lot of fermented foods and some do not. There's a lot of variability, of course. So can you elaborate a little bit on that?
Very good question. I think that there's variability from individual to individual, let alone from region to region. So many factors will influence the response to a fermented food, and it could be host factors like the individual state of health or inflammatory status or other medical conditions, or it might be microbiome factors, or it might be dietary factors. So it will definitely vary from individual to individual. And I think there's a lot of people looking at those factors to try and decide how we study that, really. I think the other point that I've just been thinking about, Jan, coming back to your previous question about, microorganism drift and things like that in fermented foods, is that there's a level of variability in the host and in the individual's response, but there's also got to be tolerance for variability in the fermented food as well, because fermented foods will vary from type to type, from batch to batch, even within the same fermented food. So each fermented food will be a slightly different if you were to profile it chemically, and microbiologically, it would be a different profile to the next batch or to, you know, the neighbors or to the other brands. So you've got this variability within the fermented foods themselves, and you've got these variabilities within the host. So I think sort of setting our tolerance limits for how much do we make health claims transferable between populations and how much do we make evidence transferable between different fermented foods as well. I think they're things that we need to navigate in this area.
Yes, so it means actually that there will be quite a large gray area where we have to move along and have discussions about functionality, safety, novelty, and so on. Thank you very much.
You can get help. You can get help with that. So here we are.
Yeah,
no worry.
I know. Thank you very much, Christophe. Christophe, he is already left. Luke, Hans, and Marla for giving an overview on the regulations and the framework of fermented foods. Thank you all the participants for keeping connected so long. I hope the webinar was informative for you. Several questions have not yet been addressed. We will come back to that later to you in due time. Thank you very much. And with this, we close the webinar. Goodbye.
Thank you. Bye-bye. Have a good day.